Good evening, everyone. So, welcome back to our session. Okay, in last class, Terraform project done, right? I done Terraform project. Got the outputs. Fine then. Oh, okay, so in today's session, we are going to speak the pending concepts of Kubernetes. So, what you asked me for PV and PVC? Huh? Data version. GitHub actions. Okay. Ingress. Okay. Then common entry point. Okay, fine. So, we'll discuss. And EKS also you asked, right? I'll cover EKS also. First of all, I'll tell about PV and PVC. Okay. So basically, you know how to get the volumes for containers, right? Similarly, pods also going to require the volume. Okay. So the volume is going to given by PV actually. See, PV is nothing but setting the volume. PVC is nothing but taking the volume. So point clear? For example, if I have a cluster, in that cluster, I'll create the PV. That can be some 100 GB. How much? A pod required 10 GB from it. Okay. That called as PVC. Claiming means what to get right. So PV means defining the total volume for a cluster, and PVC means getting the required volume for the pod. This is simply what we can call as PV and PVC in general, like very simplest meaning I'm telling. Okay. So now let's process with this one. Think online I'm audible right for all of you. Can you confirm? Yeah. So now go and see here. First of all, persistent. So concept is about volumes. In that volume, which volume we are going to speak about? Persistent. Persistent means always available, sir. What is the meaning of persistence? For example, what is the, can you tell me any real-time example for persistent? Any real life example for persistent? Real life, man, general life. Air. It is a persistent, right? Always available. Mobile always available, right? Like that. Persistent means which is always available. Persistence volumes are independent. They can exist even if there is no pod using. For example, it is the volume. It is the pod actually. Even if the pod is using the volume, or pod is not using the volume, volume will be there only. Okay. So here it is created by the administrator or dynamically created by storage class. That means how many people can create here? Either admin can create or it is going to create by the storage class also. How? Storage class. Once PV is created, it can bound to a persistence volume claim, which is request for storage by the pod. That means cluster admin will create the initial volume. Let's take it is 10 GB. How much? Now I have the pod. This pod required some volume to store content or not, sir? First one, it is PV, creating the volume with some X storage. Who is going to create this volume? Administrator. Now this pod required 1 GB from this volume. This is what we can call as PVC, claiming, persistence volume claim. Claim means what to get, right? That is, when a pod requests storage via persistence volume claim, Kubernetes will search for the persistence PV to satisfy requirement. That means this pod required 1 GB. How much? Now in Kubernetes, it is going to search for the persistence volume. How many persistence volumes I have? What is the storage capacity? Now if the request is matched, it is going to give the 1 GB of volume. If the request is not going to match, it is not going to use it. Okay, that's it. If no suitable PV is found, Kubernetes will either dynamically create a new one, or if the storage class support dynamic provisioning, or PVC will remain on-bound. That means two options will have. For example, sir, again I am telling, first of all, PV means creating the volume. Who is going to create the volume? Administrator, right? He create 10 GB of EBS, for example. Okay, it is my pod. This pod requires some 1 GB of volume. How much? If this pod requests 1 GB from 10 GB, that is called as PVC. For example, if request is matching, PV will give the volume to PVC. But here PVC require 11 GB. How much? But PV is having only 10 GB. What Kubernetes will do? Kubernetes will create a new volume automatically. It is going to create a, or it is not going to satisfy the request. Two options will. Is the concept of PV clear for all of you now? Tell me two words about PV. Huh? creating a volume in the cluster by administrator. Okay. What does this volume will have? It is going to have some X storage. What is PVC? Claiming the volume from PV. Simple example can I tell? I am PV, you are PVC. I am PV. For example, a storage means knowledge. I have knowledge, sir. Okay. I have knowledge which is created by me or some any other, like for example. So you are students, what you require? You require knowledge from me, right? If you ask me the knowledge, I'll deliver, you will be satisfied. If I can't deliver, what you will do? You will go and you will try to search for other institutes. Correct or not, sir? Same thing is going to happen for the PV and PVC. Practically clear, no? That's... Sir, PVC is nothing but to use PV, we need to claim the volume for PVC. PVC request a PV for desired specification like size, access, mode, speed, etc. Like this, we are going to see in the practical part. Okay, what is the size of the volume? How you are going to access, read write mode, how much of speed you are going to get, like that. After bounding is done to pod, you can mount it as a volume. That means bounding means what? Attaching. What is the meaning of bounding? See, it's my PV, it's my pod. If the pod get the volume from PV, that is called as PVC, right? Once bounding is done, you can use it as a volume actually. Once user finished its task with the attached PVC, can release the underlying PV and reclaim it and recycle for further purpose. That means, sir, currently this pod took how much of volume? 1 GB. From total, currently here I am having how much of GB again? 9 GB, right? If my work is done with the pods, again I can give this 1 GB back here. And again I can use for future purpose also. Is the point clear now? That's it. Now is the concept of PV and PVC clear for all of you? All in, what about you? Is the concept of PV and PVC clear? Can you please confirm me once? If it is clear, I'll go for the practical part. Okay. Fine. So here restriction. Restriction means, sir, whenever you are working with PV and PVC, first restriction is instance must be on same availability zone as EBS volume. Already you know, whenever you are working with EBS volume, instance will be on. If my server is on US East 1A, EBS is also going to be on. And EBS support only a single EC2 instance mounting. That means here, whenever you are working with PV and PVC, whatever the volume you can create, single volume can be shared to multiple servers normally. But here in this case, EBS support only single instance mounting. That means you can mount this volume to only one server with PV and PVC. These are the two restrictions. Fine. So here I have the PV and PVC and I have the deployment also. So let's go and let's do this on the practical part. I have the mini cube already. First of all, I'm going to create PV. What I'm going to create? But before that, do you have any PV? What are the mandatory fields in Kubernetes? API version, kind, metadata. API version is V1. How can you get API version is V1 and kind persistence volume? How can you get these values? By running kubectl API resources command. You know that command, right? Metadata is my PV. What is the specification? Capacity is how much, sir? 10 GB. And mode, you can read and you can write it once. Coming to the AWS Elastic Block Storage, basically, first of all, here you are going to create a volume with 10 GB. What you are going to create? Let me go and let me create a volume first of all. Remember, your volume must be on same like your availability zone. Currently, what is my availability zone here? US East. So go to here and create volume on US East 1B. I want 10 GB. Okay, that's it. So now are you seeing the volume here? It is created. Now this volume I am going to use for my PV, sir. This volume I am going to use it for my PV. FS type, that means file system type is ext4. What is file system type? So again, API version V1, kind, same volume, metadata, name is my PV. How much of capacity you are having now? Access mode is read advance, elastic block storage. You are getting the volume from this particular ID. Have you created this one? Yes or no? In file system type, ext4. Now if you go and see KubeCut will get PV. I got the PV here. This is the total volume I create for my cluster as of now. How much of volume I created? So if you want to get some other information, KubeCut will get PV-O wide. Have you got some other information here? Yes. Okay. And after that, here you can use the command kubectl. Getting complete information now? Fine. So now here I am gonna climb the volume. What I'm gonna do here? That means climbing means what I'm gonna get here. I'm gonna see my PVC. Currently, do you have any PVC? So now go here and create one PVC here. See PVC. First of all, again same thing. Here you can see the mount part and everything. Don't worry about this one. I'm going to create now what? API version is? Tell me API version. Kind. Metadata. Name is my PVC. Access mode. Read write. In resources, how much of storage you are requesting, sir? See, my PV is having 10 GB. How much? And PVC is requesting for? It is satisfying my requirement or not, sir? If it is satisfy requirement, it is fine. But PV is having 10 GB, but PVC is requesting for 11 GB. What will happen? Dynamically, it will create new one, or it will bound. Two options will be there. Have you got PVC now? Now this volume you can attach to any container. See, remember, directly PV we cannot attach, sir. Directly PV we cannot. Why can't we attach PV directly? That is my main question. Can you answer me this one? Why PV can't be attached? Tell me. A logic point, man. Why PV can't be attached by PVC? Wait. Don't use much brain, okay? It will be damaged. For example, if you go to marriage or if you go to restaurant, there will be some big dishes, right? Here, what you are having? Biryani. What you are having? You want to eat the biryani, but for eating biryani, you can't go and you can't eat on the big deksha, right? What you are going to do? You are going to take a small plate. What you are going to do? Inside this small plate only, you are going to eat. Correct or not, sir? Why? Because this big deksha is to hold the entire biryani for all the people. How can you go and eat individually? If you want to eat individually, you need to take a plate. Correct or not, sir? And you can eat it here. This is you. Okay. I know this much of drawing only. Okay. Sir, same thing, sir. It is PV in our case. It is PV. It is PVC and it is going to be pod. What it is? PV is total volume. Total volume can I give to single pod? No. Big dasha can I give for individual person? No. What I'll do if you want biryani from the total biryani, I'm gonna give a small plate. Here also from the total volume, I can give only small volume. And the small volume is going to use it for the pod. That means the small biryani is going to consume by you, user. Correct or not, sir? Is the example clear for you, no? Artha Varma. Fine. అంతే కదా no na like she is not getting the concept, I think, sir. If concept is getting like worth only, right? Okay, so now here what I'm going to do is I'm going to create a deployment. What I'm going to create? I have PV and I have PVC. Which one you are going to attach to pod? PV or PVC? PVC. Why can't we attach PV? The total volume which we cannot attach. Okay. So now write here a file called deployment.yml. Okay. It's the deployment already, you know. Sir, already know deployment or not, sir? Now see what is in the deployment. First of all, you will be having here API version, kind, deployment, metadata, something, replicas. How many replicas you are having? One. Selector, match label. Like this is still now here everything is going to be deployment only. Now here I'm using command. What I'm using? Command. In the command, what you have given? Bin bash. What I'm giving here, sir? Bin bash. After that bin bash here, I have seen hyphen C. Hyphen C is to execute the command, sir. What is hyphen C here? So sleep 10,000. What is the meaning of sleep 10,000 here? Content is going to stop for 10,000 seconds. How many seconds? Here I am mounting the volume. What I am doing? How I am mounting the volume? I am using here my PV. From this volume I am getting. It is the base actually. Okay. Mount path. You are going to give it to TMP persistence. That means in this path you are going to put the volume. Correct or not, sir? Like that. After that, whatever you have seen here, volumes. What is the name of the volume here? It is the total volume. From this volume, you are claiming it. What you are doing here? How much of volume you are claiming, sir, here? There is no value. Why? Because here I mentioned just the name of the PVC. What is the name of PVC here? My PVC. My PVC is like having how much of volume? 10 GB. That means this pod is literally going to get how many GB of volume? See, simple mounting is very easy. First of all, mount path. You are going to give the mount path here. Mount means I am getting it from my PV and it is the mount path. That means in this path, your volume is going to store. After that, here you can go for volumes. Where I am getting here? Volume from my PV. And for this my PV, what is your persistence volume claim? My PVC. Save this one now and give the command kubectl create -f deployment.yml. So this deployment got created. Give the command kubectl get pod. Have seen the pod here? Currently content is on now creating status. It was some time. Pod running now. So now what is the command to enter into the pod, sir? Exec. Okay. Kubectl exec exec -it. What is the name of the pod? It's the pod, right? And use /bin. No, just give this -. sh. So now give cd/tmp. In the tmp only will be having your volume, right? Are you seeing persistence volume? How this volume came here? From our PVC. From how it came, sir? Sure. How it came, sir? With the help of PV or PVC? First of all, it came from PVC. Where it came from? But PVC got the volume from. Clear now? That's it. So now here you can store the data, whatever you want. And what is the maximum limit for here? 10 GB. Correct or not, sir? That's it. So now exit from the container. This is how the PV and PVC is going to work in real time. The concept clear now? If somebody asks you what is PV, what you are going to tell? Total amount of storage for the cluster. That is PV. And PVC means how much of volume you are claiming. That means how much of volume you are requesting. That is PVC. Okay. And PVC you are going to use in the deployment or pod in this volume. You need to put volume, name of the PV and name of the PVC. So now open your notes, all of you, and write these notes. I'll tell you a few points. PV is the total amount of volume given for the entire cluster. PV is the total amount of volume given for the cluster. PV is the total amount of volume given for the entire cluster, and PVC means how much of volume we are getting, that we are requesting for. PV is total amount of volume given for the cluster, and PVC means amount of volume requested from the PV. Okay. Is it clear now? And who is going to create the PV? Administrator or dynamically? Like write this point also. Nice, sir. Fine. Okay, so now like we can delete this one. How to delete this one? Kubectl delete -F. What you are going to delete here? Huh? Deployment.yml. If you simply this one, everything is going to go on, and you can give the kubectl delete pvc.yml, and you can delete pv.yml. So everything is going to be released now. Is the point clear for you now? This is the concept of PV and PVC. Is it clear for all of you now? Okay, then fine. So online, is the concept clear for all of you? Can you please confirm me on chat box now? Is it clear or not? Okay, so next concept, what you asked for me, PV, PVC done. Two concepts. Next, multipod. Okay, first one you want entry point or multipod? I'll go for entry point and command difference. Then we can go for multipod designing pattern. Basically, it's not a that much of important, but of course you ask, I'll teach you definitely. So here what is now Canva projects. I'll go for Docker. In here, I can explain entry point. Of course, in Kubernetes also, anything is fine. Anywhere you can explain. Here. So here, if you can see, are you seeing entry point here? Seeing entry point here. First of all, here I am taking what, sir? CentOS image. What I am taking? CentOS image. So if you go and see, if you want to use entry point, you can use it like directly like this. Yum install -y and cmd I am putting here. So directly, first of all, difference between cmd and entry point is which one is high priority here? Entry point. Like I'll explain this one. Wait. Okay. So now if you go and see, entry point already run in cmd. This we see in practical, right? When it comes to entry point, it override the cmd when you pass additional parameters while container running. What is going to do? It is going to override cmd when you pass additional parameters while running the container. Okay, fine. It is the general way how you are going to define the entry point. For example, if I want to use this entry point, like I'll show you it, how to use the entry point. I'm going to copy this one here. So, but before that, write a Docker file. I think all of you know Docker file, right? Sorry. Docker build -t. So now if you give the command Docker images, have you seen this one? New image called Raham. From this Raham, I want to create a container. What I want to create? How can you create the container? Docker run. Okay. So now if you wait, DOM image. Okay, wait. In Ubuntu /bin. So if you go and see, have I passing parameters or not, sir? Here, if you go and see, which one has passed here? Yum install so and so parameter, right? But it is not working. So for that purpose, what I'll do, VIM in the same Docker file, I'm gonna create one more image like this, okay? You see this one? Docker run image name, HTTPD. Both Maven and HTTPD will get installed. Here you have the Maven, and here you'll be having the HTTPD. Now, if you go and see, run this one, I'll show you. Here in CMD, what you have given? HTTPD, right? Correct or not, sir? So if you go, remove everything, just get it here. Double quotes, I need to change here, wait. It's not the pattern. Is it installing the HTTPD or not, sir? How it is installing? How it is installing, sir? How it is installing means, now see the explanation here. Basically, first of all, I'm using entry point here. What I'm using? See, by default, it will execute the HTTPD command. By default, it is going to execute. If you specify this command while runtime container, it is going to execute. Now, if you go and see Docker run image name, have I given this one or not, sir? So yum install -i. But for this entry point, I have passed the parameters from CMD. From where I passed here? When I use entry point and CMD, which one is going to execute first? Entry point. But for this entry point, parameters have been passed by CMD. Is it clear now? So in this way, we can use both entry point and CMD in the same way. Is it clear now? Or what you can do is, you can use one more thing also. VIM Docker file. Oh, sorry. VIM Docker file. In the Docker file, see. In entry point, I'm running a command called sleep command. What I'm running? Sleep command. Sleep, I'm gonna run for 100 seconds. How many seconds? Or 1000. Now what I'll do? Docker build -t raham v3. Give dot. Is the image got builded now? Create container docker run -it -name container 5 with image called raham v3. Hit enter. Now what is going to happen? Container is going for sleeping mode. Which mode? Why it is going to sleeping mode means, like, let me stop this one. See, what is happening, sir, here? Container going to sleep mode. Why? Because in the entry point, I am asking the container to sleep. In the entry point, I'm asking the container to, but for the entry point, the parameters are passing from CMD, but both are working inside the container, outside the container. Inside the container, but which one is high priority? Entry point is high priority, but for entry point, where we are passing the commands from CMD. You got the logic point, no? That's it. Online, is it clear for all of you? See, like nothing is going to stop here. Am I able to stop anything? No. Of course, you can use multiple parameters also, you can pass, sir. Doesn't matter actually. So this is how the entry point and CMD is going to work. Is it practically clear now? Entry point and CMD both will be working similarly, okay? High priority will be entry point. Entry point will execute the command, but the parameters and the arguments are going to given from CMD. Even in this example also, it is installing, but what it is installing? This is passing from CMD to entry point. Here also I am executing sleep command, but for sleep command, the input 1000 seconds has been passing from CMD only. Got the logic point now? That's it. So now entry point CMD also done. Like whatever you asked me for apart from this. Multi-container pod, right? Multi-container pod you want, fine. But before going for multi-container pod, is the example clear? What you understand by this example, tell me. Eh? Both are same. Then how these are working? High priority. How it is working internally? Entry point is getting input from CMD. That is the logic part. Next, one more additional concept, multi-container pods. Okay, so multi-container pod is going to be the last last additional concept for the Kubernetes. Okay, so first of all, what is the meaning of multi-container pod? Huh? Will ask me Argo CD. Then what about it? Then later somebody will ask about help. Somebody will ask RVAC. Then what do you want to do now? Okay. Okay, fine. So let's go with multi-container pod. Basically, the meaning of multi-container pod is maintaining more than one container inside a single pod. Okay. There is a concept called container designing pattern. Which one? So there we have something called as init container, sidecar, and ambassador. Init container means, for example, this container will be working like this. It is my pod. Inside this pod, I'll be having container one and I'll be having container. This container two wants to run the application, right? But if I want to run the application, what I want to know, I need to get the code, correct or not, sir? In that case, container one will help me to get the code. After container one helped me to get the code, container will be go to exit state. It won't work anymore. Init container means it will work only one time. After once its work is done, it is going to terminate. Only secondary container is going to work. Which one is going to work? That is what we can call as init container pattern. Which one? Tell me what is the work of init container pattern? You can create multiple containers. First container will be working for only if the desired work is done. After the desired work is done, it is going to terminate. Only second container is going to run inside the pod. So this is the example for init container. So let me open this one. So now here, I'll go for the documentation. Wait, here is Kubernetes Raham. I have the things here. Okay. So give me a second here. I'm touching up the multi-container pod, right? So Helm is not HPV English history. Okay, fine. Let me take from official documentation. It's okay. Multi-container pods. So you can take any of the official documentation and I'll show you how to work with this. If you go and see, it is single container. So now I'm going for multi-container. Have you seen this one? It is the first container, right? You scroll down here. So I'm going to take an example here like this. First of all, what I'm discussing about init container, right? So copy this one. This much of example is not better. Okay, let's use ChatGPT. Why not? Like I'll show you how to use ChatGPT also for it. For example, if you go in ChatGPT and ask example for multi-container pod. See, already you know how to write a single pod, right? In that single pod only you are going to get one more additional content information. That's it. Apart from that, nothing is new here. If you go and see, already from here to here, you know or not, sir? But after that, what you are getting some hyphen name, image, command for the content. That's it, right? So nothing more new. Already you know this command, okay? Like this was VIM pod.yml. So paste it here. So here I'm creating multi-container pod. That means more than one container. It is the first container image. It is the first container name and ports is this one. Here second container name, second container image. In the second container, I am running a command sh. Sh is to run the shell command. -c for command here. I am printing something called echo hello from the busybox container and sleep is equal to 3600. Now see kubectl create -f pod.yml. Oh, sorry. Pod.yml. Kubectl get PO now. You can see here clearly 0 by 2. 0 by 2 means total you are creating 2 containers. How many containers? Total number of containers are 2. But currently how many are ready? 0. Have you got 2 by 2 now? Kubectl describe pod. Name of the pod is going to be multi-container pod. Hit enter. Are you seeing multi-container pod? First of all, it pulled which one, sir? It pulled the Nginx image. Which image? The second image. Is it clear now? And you can see the complete information of the each and every container here. Is the point clear for all of you know? Clear or not, sir? That's it. And if you want to get the pods of first, if you want to get the logs of first pod, use this first one. Okay. This is going to tell the logs of the pod called multi-container pod. And from which container? Container one. What is the container one name? Nginx. Are you getting the logs of first container? No, sir. If I want to get the logs of second container, kubectl get logs. Name of the pod -c stand for container. Which one? What is my second container? Busybox container. Write this one. Is it printing hello world message or not, sir? In this way, you can create the multi-container pod. So in multi-container pattern, we have first of all init container. What is the work of init container? After working it's done, it is going to. And there is something called as side pattern. I mean like sidecar pattern. It is called as which one? Basically, I have my own documentation for it, but unfortunately in this laptop, I'm not able to find it. Okay, fine. I think it's wait. I got it. It is here actually. In the Kubernetes here. But I need to search a lot of time. Like it will take a lot of time literally. That is the reason I'm using some Google examples for it. See, in 300 pages, you are going to search for it. And that too, it is going to have completely 20 chapters here. In these 20 chapters, I need to search one by one for to get this example. It is somewhere else. It's not here. It is somewhere else. Okay, fine. Let's leave it. So I'll use this one for as of now. Is the first example clear for you now? Of course, you can give 3-4 containers also. But remember, whenever you are creating the multiple containers in same pod, it will share same network, same volume also. Already we discussed this point. Okay. So this one done multi-container pod. Already just now I see. Next year, designing patterns of multi-container. Basically, In the first one, I'm going to teach about sidecar pattern. Which one? Sidecar is nothing but simply helper. Which one? Helper. I'll tell you an example. For example, if you go to home, if you are very tight, your brother is going to come to you and he's going to help you or not, sir? You need to do 10 works, but your brother will come and he's going to help us on some works. Same here. Whenever you are having the pod, for example, I have the pod. In this pod, I am going to do two works. One is writing the logs. Second one is sending the logs. If I write the logs and send the logs with the help of same container, my work is going to be very, very difficult. Correct or not, sir? My work is going to be very, very difficult. For that purpose, what I'll do, I'll create two containers. I'll ask first container to write the log files, second container to send the log file. Now, work is distributing or not, sir? Simply sidecar is nothing but our helping partner for the container. Simply. If you don't want to do entire work with a single container, you can create one helper container. That is what we can call as sidecar design pattern. Which one? So here, this sidecar design pattern consists of the main application, that is web application, and helper consists of the responsibility. Okay. So main container will be there and helper container will be there. That's it. Second one is going to be adapter. Which one? Sir, in adapter, what exactly will happen? The adapter pattern is used to standardize the output from primary container. Standardizing refers to format of output in a specific manner. That means, for instance, adapter container could expose the standard monitoring interface of the application, even though application does not implement in standard way. That means, see, if main container is not working properly, this adapter will ask main container to work properly. Is the point clear for you? Adapter container takes care of transforming the output into the who is acceptable at the cluster level. Like simply, if you want me to tell, see, what is the purpose of application container? Write the complex monitoring output. If this application container is not writing the output standard way, this adapter is going to tell, no, basically you are doing the wrong work. You can do the work very easily. That means simply, I'll take one more example. Initially, you are practicing everything in manual setup. You will get the output. But I gave you Tomcat script or not, sir? Even Tomcat script also working fine or not, sir? Which one is better now? Script. That means you are working very hard. I am coming and I am simplifying it. Here also, application container is writing the complex monitoring output. But the work done by application container is going to simplify it by the adapter container. Which one? This is what we can call as multi-container pod designing. Is the concept clear for all of you know? In multi-container, we seen example of multi-container. We seen sidecar pattern. We have seen adapter. And third one is going to be ambassador. Which one? Ambassador. For example, see, here my application container need a database connection. What it need? Ambassador provide the proxy database connection. That means whatever my application container need, it will gather the requirement. This ambassador is going to helpful for it. Simply, the ambassador design pattern is to connect the containers with outside of the world. That means you have this container. You want to connect to this outside. Are you seeing local testing and production? If you want to connect these containers to outside of the world, which container pattern you are going to use? Adapter. Is it clear now? So 3 designing patterns I said you. How many? First of all, let's see this simplified way. So here I am writing. First of all, what is the meaning of multi-container pod? Multi-container pod. So here I'll show it from you. I'm giving the content. In Kubernetes, multi-container pod is a pod that contains more than one container. Containers within the same pod can share same network, same namespace, and allowed to communicate with each other. And they can share the volume also. Okay. So here we have seen one of the example for multi-container pod. Let me give this example. Cat. This is the example, right? So here, how many types we have seen in multi-container pod? First of all, we have seen Sidecar pattern. Which one? What is sidecar pattern? What is going to tell you? I like I'm going to write it on simplified way here. Like, let me show you. Sidecar pattern. Sidecar pattern consists the main application, that is web application, and it helps the helper container to responsible for the requirement. That means simply the sidecar designing pattern aim to resolve the exact problem. What is the problem here? Sidecar pattern consists of main application. After that main application, you will be having one helper container. Which one? Helper container is responsible for doing some X work. Which work? That can be any work. Okay. So here I am giving this example for you, for your clarity. Okay, guys, not only telling this example, you can tell any example. But as of now, I am not able to find my own documentation, so I am using this one. Don't worry. So simply in simplified word, I'll write on my own words, not to use this one. It creates a helper container to main container. Okay, main container will have application and helper container will do help for main container. Is it clear now? Second one is going to be ambassador. Which one? Sorry, adapter. Adapter means what is the main purpose of adapter here? It is going to simplify the work of the main container. Is it clear, sir? Here, adapter pattern is to standardize the output of primary container. Okay. That means it is going to make the work of the primary container simplified. Simplifies. Simplifies the which pattern? Output pattern. Which one? Standardize simplifies the, or like simply standardize the output pattern of main container. Which one, sir? What is the example? You are working manually something. I gave you a script. That is the example. Now, what is the last one? Ambassador. What is ambassador for? Use it to expose the main container to the outside of the world. This one. Use it to connect the containers to outside of the world. Is it clear now? There is one more thing called as init container design pattern. Which one? What is init container? It initial the first work and later it is going to terminate. What is the example? Init container will bring the GitHub code. After exiting, our application will take the code from the init container and it is going to work. So this is the example. So now is the container designing pattern clear? That's it. There you go. Okay. Okay, still what do you want to learn? Okay, Ingress is pending, right? Let me cover Ingress. What is the meaning of Ingress first of all? This in real time, yeah, for logging purpose we use. Logging purpose. And getting the code, we will definitely use it. So these are the two use cases. For example, if you want to access the application, first of all, you are going to log in the application or not, sir? For logging purpose, I'll ask the sidecar. You take the logs and accept the user. Now user will use my container to work. This is one of the use case. For ambassador, like if you want to expose any kind of application, you have two containers. Container one you want to expose. In that case, container two is going to speak with your proxy networks. Okay. Sure. Two containers will be main containers. One will be ambassador, adapter, sidecar, init container. You can also define like that. Okay. Fine. So next one, what is the last pending one here? Kubernetes Ingress, right? Kubernetes. What is Ingress? Huh? Load balancer. Of course, Ingress load balancer. I'll teach about like guys. This Ingress is very lengthiest topic, but I'll try to make it easy for you. Okay. First of all, Ingress main purpose is to expose the application to outside of the world. Just like our services, it is also one of the service we are having. If external want to communicate with our internal Kubernetes, we are going to use the Ingress. For example, you are some external user. I'm having my Kubernetes cluster. If you want to communicate with my cluster, you can use Ingress for it. For example, if I am having an application, I want to access the application. It is running inside we can use any service, cluster IP, node port, load balancer. But for cluster IP, node port, load balancer, we are going to use IP, which is going to expose. Is IP exposing? Are we going to recommend? For that purpose, we are going to use DNS here. What we are going to use? Instead of using IP address, suppose server, we are going to use our code DNS. That means you can create your own DNS. www.raham.com, www.mahesh.com, anything you can use. Okay. Here in Ingress, we have controller which is attached to the load balancer. In Ingress, we will be having controller. Already I said in Kubernetes, we will be having lot of controllers, right? So in this, we have one more thing called Ingress controller. In all clouds, we'll be having controller. For example, in main server, that means control plane. Control plane means your master. You will be having API server, etcd. Later what you have? Scheduler and finally controller. So this controller, we will be having a number of types: network controller, service controller, Ingress controller, volume controller, node controller, everything will be there. So what is the work of this controller? You know, when you give raham.com, it is going to control by the DNS. Raham.com is DNS or not, sir? This is going to be managed by my Kubernetes controller. Who is going to manage this? Here we have an API for the Ingress, which will be communicating with the services. Which API is going to communicate with service? When you use Ingress, Ingress will have API. That API is going to communicate with the Kubernetes services. Which services? Ingress need to connect to the load balancer and connect to the Kubernetes API. That means if you want to create this service need to connect to Kubernetes API. And same time, it need to connect to the DNS load balancer also. Which load balancer? It is simply like external load balancer. What is external load balancer? Already I said this, sir. External load balancer means it is going to expose the application to outside. Simply web server. Which one? Simply I'll tell you one thing about Ingress. Cluster IP, node port, load balancer will definitely require IP address. But if you want to expose your application with your own DNS, you can use the Ingress. What we can use? Ingress will be having the communication with API and it is going to automatically create a load balancer. Which one? It is the safest way to expose the application in real time. Why? Because you are not exposing IP address, right? Are you exposing an IP address anywhere? No. So now here you can see, if we use Minikube, we can use Nginx. If we use Kubedium, we can use Nginx or Traffic. It is one of the separate tool actually, okay? But in cloud, we need not to do anything. Why? Because in cloud already we will be having a load balancer by default. For example, if your cluster is on-prem cluster, which one? For on-prem, do you have load balancer by default? No. For that purpose, you can use Nginx Ingress controller or Traffic Ingress controller. But whenever you are using your cluster on cloud, cloud will create one default load balancer, right? That means we need to create only Ingress service and tell them to connect to CIP or node port. That means when you create Ingress service, we need to tell you are going to use cluster IP or node port, and Ingress will be working for both HTTP and HTTPS. If you talk about cluster IP or node port, Are they going to work with HTTPS? Never. By default, the cluster IP node port will work with HTTP port. Which port? But Ingress is not like that. Ingress will work with HTTPS. Three main points about Ingress. It's a safest service used to expose the Kubernetes applications. While using Ingress, we are going to expose the application with the DNS, not with IP address. Third point, Ingress will be having load balancer by default created. Fourth point will be it is going to support both HTTP and HTTPS routes. Remember these 4 points only. No need to remember this much of length. Remember, sir, by default, when you are working with Minikube, you need to add on the Minikube basically. Like Ingress. By default, if you give the command Minikube add-on list, now you can see list of add-ons. By default, if you go to Ingress, is Ingress enabled or disabled, sir? By default, it is going to be disabled only. We need to add on. So how to add on this service means Minikube add-on enable Ingress. If you run this command, now is Minikube is going to enable Ingress or not, sir? See, Minikube is single node cluster, right? All the functionalities will not work. We need to enable some functionalities. If you talk about metric server we enabled or not, sir? Why? Because Minikube is single node, na? By default, all function will not be there. Now, if you go and see Minikube add-on list, previously it was disabled, but now it is enabled. Clear or not, sir? And of course, if you want DNS enable, you can enable Minikube enable Ingress DNS. It is optional. If you want to enable, you can enable. I am also enabling this one. Now, this both enabled or not, sir? These both are enabled. Now go here. Currently, you are not having any deployment. I am gonna remove each and everything from my current namespace. Give the command kubectl get all -n default. It is going to list everything from default namespace, right? I'll be having only one port. And one more thing, don't remove this Kubernetes service. It is by default service. You cannot remove this. Oh, wait. Is the pod gone now? Now I'm creating a fresh pod. What I'm creating? Step number 1, knowing about Ingress. What is Ingress? Say service. What is the best advantage of Ingress? We can expose the application with DNS and it is going to support HTTP and HTTP routes. It is far more advanced than remaining service. And Ingress lead the load balancer. What it is going to need? These 4 points, just remember, fine. By default, Minikube is not going to have Ingress. So we need to add on. So I just add on the Minikube Ingress here. Create a pod here. After creating the pod, attach service for it. I am creating both of them at a single time. Sir, here I am creating pod and service at same time, sir. What I am creating here, both pod and see. Okay, I am creating pod and service at same time. Give the command kubectl create -f pod.yml. Oh. Now both pod and service got created. Once it got created, now you can list the service and give the command minikube IP. If you give the command minikube IP, you will get the minikube IP address. It is your IP address, right? Now, if you use the curl command, it is not going to work for you. So, for example, curl http :// it is your IP address. What is the node port you have given? 30001. Are you getting it or not, sir? Currently, you are seeing the Nginx page. Which page? That means you are able to access the application. But how you are accessing with the help of IP address or DNS? IP address. So it is not a safest method. For that purpose, what we are doing now? We are going to convert this IP address into. Now, how to convert the IP address into DNS means that is our main point. First of all, KubeCut will create Ingress. I am creating an Ingress service. What I am creating? Here rule I am creating for front end pod. What is the HTTP rule? 80. And here one more rule I am adding, that is welcome. What I am using here? Let me apply this, you will get the point. Once it got created, now give the command KubeCut will get ing. ing stand for, are you seeing Ingress service got created? This is the IP address. This IP address what we are going to convert into DNS. How you are going to convert IP address into DNS is here this one. By using etc host, go here, write minikube IP address and write your DNS name, which DNS you want. But before that, give the command KubeCut will get endpoint. Which one? By default, if you go ahead and see, there will be no endpoint given by default. So what I'll do is VIM etc hosts. Here, first of all, you need to copy which IP address? This IP address. And now paste it here. But here I'm gonna give it as raham.com. What I'm giving? The moment if I give this one, now I am not going to access anything from the minikube IP address. Now directly I can use something called as ping and call raham.com. So now use ping raham.com. Is it getting the response from outside or not, sir? So now I'll use here like this. Instead of minikube IP address, can I use this one? HTTP colon raham.com. Am I getting the application or not? Ping is also not required. Let me remove this one. Now, how you are accessing the application, sir? By using the IP address or by using DNS? DNS giving me the application. That's it. And one more thing is here you can get like this. Give the command curl command. Which command? Call is nothing but check URL. Are you getting the application or not? That means you can use the command call http raham.com or call raham.com. Anything is fine. If I put https, here it is not going to work. Why? Because we need to install some SSL certificate for it. What we need to install? That is again a very big process. As of now, we are not going for it. So that's it, sir. This is the endpoint. And you can give raham.com/welcome. Even though if you get welcome, are you getting your website or not, sir? Are you getting this DNS? How it is getting? Because instead of I'm using IP address of any server, I'm converting the IP address into DNS, and the DNS is going to expose by the Ingress service. Are you seeing Ingress service is giving me now? That's it, sir. It is by default page, but of course, if you want to create your custom page also, you can create your custom page. That's it. Simply 4 points about Ingress. First point number 1. Ingress is safest way to expose the application. Why safest way? We are using DNS instead of IP address. So we are creating our own DNS. Are you paying money? No. Second thing, HTTP and HTTP both you are going to support. Correct or not, sir? And Ingress can create a default load balancer. What is it can create? You want me to show? By using this load balancer, we can expose the application simply. Correct or not, sir? Wait, I think KubeCut will get SVC. In this serving, are you seeing the load balancer is currently on pending status? If you wait for some time, you can get the load balancer. What you can get? Load balancer DNS. From the DNS, you can expose the application. That's it. So, clear now? Ingress is exposing the application without exposing IP address. It is going to use the load balancer. Third point is it can use the HTTP and HTTPS routes. And to create DNS, are we going to pay any money? By default, Ingress is not going to enable on Minikube. We need to enable it. But for KubeADM or K8s, it is going to enable by default. So that's it. How many concepts we covered? PV and PVC, entry point and command. And after that, we covered multi-container pod and container designing patterns 4 types. And after that, Ingress. That's it. Can I teach you one more topic also? Write the heading of static pods. Static pod. I'll just give you the intro of static pod. And daemon set is done, right? What is daemon set? I said this point. Deployment will create multiple pods, but daemon set will create one pod per one server. Sure, I'll upload the notes, okay? Vijaya, you want some affinity, anti-affinity, okay? Sure. Simply, I'll explain in couple of meanings, okay? Static pods is nothing but pods which are going to create with the manifest file without running the kubectl create or apply command. Static pods are nothing but the pods which are going to create directly without running kubectl create or apply command. And one more thing, static pods will be running on worker nodes majorly. Static pods will be running on worker node majorly. Kubelet will create the static pods. Kubelet will create the static pods. Hmm? Copies. Okay. So API server cannot control the static pods. Okay. Only kubelet will control the static pods. But kubelet will create a copy of the static pod in API server also. Simply one meaning. Basically, every pod is going to create by Kubernetes API server only. But the static pods are going to create by kubelet in worker nodes. Once kubelet creates the static pod on worker node, it is going to replicate to the master node also. But again, master node cannot control the static pods. Only kubelet will control this. Okay, that's it. I hope it is clear for you. Let me give the notes for you first of all. So here I have given everything, and one more thing is, wait, let me give this one also. History also you want, fine. First of all, we discussed about PV and PVC. Next, entry point versus CMD. After that, we discussed about multi-container patterns. And after that, finally, ingress service, right? Where is ingress here? Ingress. Ingress is written here. So this document I'm going to give on the Google Classroom for you. Take it and read it. So now, guys, have seen the syllabus copies. Anything pending from my end? Almost all, apart from like this thing, we already covered majority of the topics which is outer part of syllabus. Okay, but if anything is pending, please let me know. Okay. Mostly, I hope I covered everything. I hope so. Fine. So we can use Prometheus Grafana for it. Like no need to use the dashboard. Why? Because in real time also we are not going to use Kubernetes dashboard. So a lot of people use Prometheus Grafana for it. Hope it is clear. Nikhil, which one you are practicing? Like I'm not getting your exact like mistake. Like from which concept you are practicing? Terraform. Huh? Okay, so Nikhil, just please ping me on the LinkedIn with your like what we call this one error. Okay, please ping me there. I'll try to reply from there. Okay. Okay, then. So anything from your end, guys, is pending? Nothing. So then, are we good for today? Okay, then. So thank you for joining today's session. So let's meet on tomorrow's class. I hope you are happy with this class, right? Okay, then. So tomorrow will be the last class, and I'm gonna tell you resume building and real-time activities and career guidance. Okay, all will be done by tomorrow. Okay, then. Thank you all. You can leave now. Bye. Vijay, I'll try to cover you tomorrow.